Next, I welcome you to this online tutorial. We continue with item 16. Now, item 16 is similar to the previous item which we have just seen. I think it has been item 13. What does it say? It says that James, a younger researcher, investigates gaseous hydrocarbons from industrial waste combustion near a petroleum refinery. His analysis on gas X was found to contain 85.7% carbon and the rest hydrogen by mass. To identify its molecular structure, he examines its composition, reactivity, and environmental impact, aiming to determine its potential applications and hazards, but still remains unable to reach the goal. So we have been given analysis of a gas X, which contains 85.7% carbon and the rest hydrogen. We don't have percentage of hydrogen. Then additionally, we have been given the information on molecular mass. What does this information say? It says that 2.6, take note of this, 2.6 grams of X, 2.6 grams of X occupies a volume of 1.12 decimeters cubed at STP. 1.12 decimeters cubed at STP. Determine molecular formula. So in this case, we want molecular formula. But remember, to find molecular formula, you need molecular mass. You need molecular mass. So this information, 2.6 grams, take note of it, 2.6 grams, occupy a volume of 1.12 decimeters cubed at STP, will help us determine molecular mass, which we shall use in determining the molecular formula. Then this information for it helps us to determine empirical formula. Now I go to my response. Below is my response. Hope it is item 16. So we don't have percentage of hydrogen. We start by determining percentage of hydrogen. We have 100 minus 100 because it is the total percentage minus that of carbon. And we obtain 14.3%. Now I have percentage of hydrogen. I also have that of carbon. Step 1, we write elements present. The elements present in this case, we have carbon and hydrogen. Step 2, write percentage composition of each of the elements. So percentage composition, that of carbon, it is 85.7 and that of hydrogen is 14.3. Step 3, calculate number of moles. To calculate number of moles, you divide the composition by the relative atomic masses. Now the item will give you information on the relative atomic masses. The information may not necessarily be attached directly to the question, but you check the front page of the question paper. So in this case, for carbon is 12. Its relative atomic mass is 12. That of hydrogen is 1. So we are going to divide 85.7 by 12 and 14.3 by 1. Therefore, we shall have the following. Then, after dividing and calculating, we obtain 7.142 and 14.3. Next, we determine the simplest mole ratio. To determine the simplest mole ratio, you look at these two calculated moles, then you divide by the smallest. This is the smallest. 7.142 is the smallest. So we divide both of them by 7.142. Therefore, we shall have this division. Then after dividing, in this case, here we obtain 1 to 2. We obtain 1 to 2. And as a result, empirical formula for carbon, we shall have a 1 there. And for hydrogen, there is a 2. And this is the same as having CH2. So this is the empirical formula. Now, having determined the empirical formula, now we proceed to determining the molecular formula. To determine the molecular formula, what do we use? We use empirical formula times N equals molecular mass, but the item did not give us directly the molecular mass. That information was not given directly on the molecular mass, but something was given. There is that thing which I was telling you to take note. That information which was saying, look at that item. That information which was saying that 2.6 grams 1.12 decimeters cubed, 2.6 grams, that a volume of 1.12 decimeters cubed occupy what? I have forgot. 1.12 decimeters cubed occupy, let me check. They occupy 2.6 grams. This information was given in the item, if you cross-check. So if this volume occupies this mass, what of 1 decimeter cubed? So 1 decimeter cubed will occupy 2.6 over 1.12. Now we want molecular mass. That's why you are seeing mass on the right-hand side. Yes. What you want should always be on the right-hand side. Then what of the standard at STP? 22.4. Now you may ask, why are you now bringing in 22.4 decimeters cubed? 22.4 decimeters cubed is the volume at STP, and this is the one that represents 1 mole, and 1 mole is molecular mass. So therefore, what of 22.4? This will be 2.6 over 1.12 times 22.4 grams. And calculating this, we obtain molar mass as 52 grams. Alternatively, another learner can decide to use another approach. Now that learner will come and say, what do I have? I have 1.12 decimeters cubed, and these are equal to 2.6 grams. That is what the item specified, that this volume has that mass. If this volume has this mass, then what of the 22.4? Why 22.4 decimeters cubed? 22.4 decimeters cubed is the standard volume that represents 1 mole, which is the molecular mass. Then you ask ourselves, what of 22.4 decimeters cubed? They contain how many grams? Now to find these grams, we are going to cross multiply. 22.4 multiplied by 2.6. So we are going to have 22.4 times 2.6, then divide by 1.12. We have seen already such conversions before. Therefore, molecular mass will have, we shall have 2.6 times 22.4 over 1.12. And calculating this, still we obtain 52. Now I have my molecular mass. Then I can compute the molecular formula. So we have empirical formula times N equals molecular mass. The empirical formula, I substitute it. I also substitute the molecular mass, which is 52. Then I compute here. I substitute carbon. Carbon is 12 and it is 1. Then plus hydrogens, there are 2 of them, but each hydrogen is 1. So we shall have 1 times 2, then times N, and this is equal to 52. Then calculating this, we obtain 14, N equals 52. 14n equals 52, and dividing both sides by 14n, we obtain n as 3.7. 3.7 can be rounded off to obtain 4. Then we round off to the nearest whole number to obtain a 4. Then I substitute back my value of n. So molecular formula will be, on empirical formula, I substitute n, which is 4. And this 4 multiplies on carbon and also multiplies on hydrogen. Therefore, after multiplying, this will be my molecular formula. And this marks the end of item 16. So allow me first stop here for item 16.